two circular flower beds have been shown on two sides of a square lawn, ABCD of side 56. If the center of each circular flower bed is a point of intersection O of the diagonals of the square lawn, find the sum of the areas of the lawn and the flower beds. So in this figure, we have first a square. ABCD is a square with side 56. Then we have two sectors. With OS center, this is one sector, and again OS center, we have the other sector. And we need to find the area of the entire lawns. So we need to find the area of this square plus these two segments, the area of this entire lawn. To find the area of this entire lawn, we'll divide the figure into two parts, in fact 4 parts you can say. First, I will find the area of these two triangles, this triangle OAB, and then triangle OBC, these two, and then they both will have the same area, and then I will find the area of the sector AOB and the sector ODC. So this is how we are going to go about our sums. First find the green area and find the blue area and then add them up. The first step of the sum is to find DB. This is DB. Now to find DB, we will take up the triangle BCD, and we know the triangle BCD is a right angle triangle. So triangle BDC. So we know angle, this angle here is a 90 degrees because it is the angle of a square. So angle C or BCD equal to 90. Reason, angle of a square. Now we go and use Pythagoras theorem. So we got to first identify the hypotenuse. If C is the right angle, your hypotenuse will be BD. This will be the hypotenuse, the side opposite the right angle. So we have BD square equal to DC square plus BC square. BD we do not know. BC square is 56. All the sides of the square are equal, so this is 56, this is 56, and here too is 56. So this is 56 square plus 56 square. Now you do not have to find out 56 square. This is 56 square, 56 square. 2 times 56 square. So BD will be under root of 2 into 56 square. So BD will be 56 under root 2. This is part 1 of the sum, where you found BD is 56 under root 2 centimeter or meters. Now the second part, now that we know the BD is 56 root 2, here is BD is 56 root 2. You'll definitely agree that OB is equal to OD, which is equal to 56 under root 2 over 2, half of it. So that comes to, so this is now 28 root 2. The OA will also be the same. OA and OC will also be 28 root 2, because we know it is a square, and if it is a square the diagonals are equal. So I got here 28 root 2, this is 28 root 2, 28 root 2 and 28 root 2. All these are 28 root 2. So now I'm ready to find the area of AOD. In the earlier figure, we found OD, OC, OB and OA. All of them were half of BD, that is 28 root 2. Here was 28 root 2, 28 root 2 and 28 root 2. Now this angle we know is 90, because in a square the diagonals bisect at 90. So we can now find out the area of this triangle, half base into height. This triangle, we know this is 90. We'll mark this as O. So we have now area of AOD is half base into height. Now half, the base we know is OA and the height is OD. Let me explain that again. So this could be called the base, this could be called the height, or the reverse also. We could call this as a base and this is the height. What is important is the angle between them is 90. Like if you have a right angle triangle in this manner, and if this is 90, then you will call here this base height, or this is height, this is base. Now to put the values, half, we saw OA 28 root 2, OD is also 28 root 2. So you cancel, this is root 2 is 2, so it will be 28 into 28, and this is 784. Now the area of the other side is also the same, area of BOC, this area BOC will also be the same, will also be 784. Now that we have found the area of the green portion, let's go and find the area of the two sectors. We'll find the area of this sector and area of this sector. So here, so area of sector AOB, and you know area of the sector formula, theta 360 pi r square. Now in this the theta will be 90, because the diagonals of a square meet at 90, and we've already seen the radius, we found the radius here as 28 root 2. So let's put the values. So for this we have theta equal to 90 and radius as 28 root 2. So put the values. So we have 90 over 360, pi is 22 by 7, 28 root 2 the whole square. On reducing it 1 by 4, 22 by 7, and this would be 28 into 28, root 2 is 2. So now we cancel. On reducing this, we get 7 ones are, 7 fours are, this would cancel out, and now you will have 22 into 28 into root 2, which is 616 root 2. The area of the other sector on the other side is also the same. Here we have another sector here which will have equal area, that is ODC will also be 616 under root 2. Here's a small mistake, this should be here also under root 2. So this is under root 2, so this would be 1, 2, 3, 2. This area is also 1, 2, 3, 2. Because this is under root 2 into under root 2, it is under root 2 square. Here's a mistake, I'll just do this up again. So we have 90 over 360 into 22 by 7, 28 root 2 into 28 root 2. So many centimeter square. So total area of both the sectors is 1232 plus 1232, which is 2464. Now next, earlier we found out this area. In the earlier slide, we found this area as area of a triangle. So now it's time to add up all the 4 areas and to find the total area of this figure. These areas we found as 784. This was 784. Now here we found 1232 and this was 1232. So total area equal to 784 plus 784 plus 1232 plus 1232, and this totals up to 4032 meter square. So for the answer, area of the lawn (4032 meter square). Find the area of the shaded region in the figure 12.16 where ABCD is a square of side 14. So to find the area of the shaded region, first we need to find the area of the square ABCD. After we find the area of the square ABCD, we will now then find the area of these circles, these 4 circles. When we subtract the area of the circles and the area of the square, what remains behind will be the shaded region. This is a shaded region. So first we need to find, we said, the area of the square. So to find area of square ABCD, area of the square we know is side into side. The side is given as 14, so it will be 14 into 14, and that is 196 centimeter square. So first step done. Now next we need to find the area of the circles. So you have these 4 circles. We have to find the area of these 4 circles. However, to find the area of a circle, you must always know its radius. Now the radius of the circle is not given, but it's given to us that this is 14. The side is 14. And if you look up, the side is made up of one radius and another radius, another diameter, not radius, another diameter. So what I'm going to write here is AB equal to 14, this is given, but AB equal to diameter plus diameter, 2 diameters equal to 14. So that means 1 diameter equal to 7, and if diameter equal to 7, we know radius is 7 by 2. That means this diameter we have taken as 7, and the radius here will be 7 by 2. This is 7 by 2, here 2, we can put up the center, and this will be 7 by 2. This is the center, 7 by 2. So for second step, area of circle is pi r square, but we have 4 circles, so area of circles, all circles, that is 4 circles, will be 4 into pi r square. Let's put up the values. Pi 22 by 7 r square, 7 by 2 into 7 by 2. So we cancel this up, 2, 2, 4. So this is equal to 4 into 22 into 7. So that is 616 centimeter square. Now for the next step, now that we found the area of the square, 196, and now we found the area of the circles. Now the next step is to subtract both of them, and when we subtract, we will get the area of the remaining portion. Here this is again a mistake. This should be 22. 4 is already cancelled out, so this is 22 into 7, which is 154 centimeter square. So back again, first we'll write down the area of the square. So area of square equal to 196 centimeter square, and from there we are going to subtract these 4 circles, which we found the area as 154. Subtract the area of these 4 circles. So area of 4 circles equal to 154. Now to find the area of the remaining portion, we need to subtract both these. Here, this is the remaining portion that we need to find, and that would be area of shaded region will be area of square minus area of 4 circles. So area of square was 196 minus 4 circles, 154, and this is 42 centimeter square. So the answer, area of shaded region equal to 42 centimeter square. Find the area of the shaded design in the figure 12.17, where ABCD is a square of side 10 centimeters and semicircles are drawn with each side of the square as a diameter. So in the sum, we need to find the area of these 4 petals. 1, 2, 3, and 4. Now to find the area of these 4 petals, in the first step, we'll first find the area of the square ABCD. So let's go ahead and find area of ABCD, and ABCD is a square, which means side into side, and the side is given as 10 centimeters. So 10 into 10, and that is 100 centimeter square. Then from there we will subtract these 2 semicircles, area of this semicircle and the area of this semicircle. So when we subtract the 2 semicircles, which area remains? Area 1 and area 2. So in step 2, we do area of 2 semicircles. 2 semicircles means 2 into, we know semicircle is area of circle pi r square divided by 2. Now we put the values here. We have 2 into pi is 3.14. They've asked us to take pi as 3.14. Now for the r, this is given as 10. So the diameter is 10, and you'll definitely agree the radius must be 5. So this is 5 into 5 over 2. So I cancel this out. So I get 5 into 5, and this is 78.5. So to find now the area of 1 and the area of 2, I need to subtract the square minus a semicircle. So area 1 plus area 2 equal to the square 100 minus semicircle 78.5. So this equal to 21.5 centimeter. That will be area of 1 plus 2. So in the earlier slide we found the area of 1 plus 2 is 21.5. So this is 1. And this 2. 1 plus 2, no, 1 plus 3 it is. So let me write this. Area of 1 plus 3 is 21.5. Back again here, this is 1 plus 3, not 1 plus 2, 21.5. Similarly, the area of 2 and 4 will also be the same. This area. So area of 2 plus 4 equal to 21.5. So now if we add up, we will get area of 1 plus 2 plus 3 plus 4, which is 21.5 plus 21.5, which is equal to 43. So we know this total area. So this area 1, 2, this is 3, this is 2 and 4. This total area we got is 43 centimeter square. To find the area of this pattern, you would agree you got to do area of the square minus the area of 1, 2, 3. So to find this area now. So area of shaded region, or this orange area of design I will call it. To find this area we need to take up the area of the square, this entire square ABCD, and from that area we need to subtract this area 1 plus 2 plus 3 and plus 4, and what will remain will be the area of that shaded region. So area of the square we already have found earlier, and that was 100 into 100 because it was, this side was 100. So this was 100 here, and area of this blue region we found was 43. So here it will be 57 centimeter square. So this area is, total area is 57 centimeter square. To go over the sum again, in step 1 we first found area of the square 10 by 10, that was 100, first step. Then in the second step we found these areas, area of 1 plus 3, then we found 4 plus 2, these areas in the second step, these blue areas. These 4 areas we added up, we found this total. And in the, then when we subtracted, suppose we had the area of this square, and from this area of the square we subtracted the 4 areas, this area 1, these 4 areas, when we subtracted, what remained was that flower, was this pattern. here. This was the area what they asked us. So area of square, we did area of square, which we found was 100. From there we subtracted this 4 areas, 1 plus 2 plus 3 plus 4. That area was 43. And on subtraction of both these areas, we got area of the petals or the design, and that was 57 centimeter square.